All right, guys, complete to do now. Okay, so who wants to give me the first layer? Noah?
It's the thinnest layer that's made out of rock. Also,
All right, so the crust, the thinnest of the layers, solid rock. You have two types of crust, oceanic crust, continental crust. Good. Give me the next layer, Arlene. So it's neither solid nor liquid, it is in between. Remember, we call that a semi-solid. All right? So what can you tell me about the temperature now in that layer? It's hot, right? Because again, you're taking solid rock and you're basically turning it into like a goo, right? Like magma. So it is hotter. Pressure also increases, all right? And so does the density of the material. Now, what is the next layer? So we have the crust, we have the mantle. Melissa? The outer core. And what's significant about the outer core? All right, so it is a liquid. Now we're not dealing with rock anymore. So it's liquid made up of iron and nickel. All right, the temperature is hotter, but the pressure is not so much where it can't exist as a liquid. I think that's what you said at the end, right? Okay, that it won't turn solid. Good. And then the last layer, Jamie. Inner core. And what can you tell me about the inner core? Okay. What about the state of matter? And when I mean by state of matter, I'm talking about whether or not it's whether it's a solid, liquid, or a semi-solid. So what is the inner core? Which one of those three?
solid.
It's a solid. Good. And the two metals that make it up? What are the two metals that make it up? Iron and nickel, same as the outer core, okay? All right, so what we're going to talk about today are what we call convection currents. And convection currents have to do with density. Now, what can you tell me about hot air? Hot air. Does hot air sink? Warm air does what? Rises. Does anybody know why it rises? Why does warm air rise? Remember, I just said what I'm about to talk about has to do with density.
The higher is lighter. It's lighter. It's lighter.
Yeah, it's warmer things are less dense. So density is defined as the amount of matter in a given volume, right? So what happens to the motion of molecules when we heat them up? Come on, you learned this last year, Melissa. They get faster and they spread out, right? So now if these molecules are spreading out, I have less material in that same volume. Becomes less dense. Things that are cooler, the molecules are closer together. All right, so warm air is going to rise because it is less dense. Cold air is going to sink because it is more dense. All right, so when you're boiling a pot of water on the stove, right? All right, so what happens is the bottom of the pot where the water is in contact with heats up and becomes less dense. That rises to the top of the pot. The water that's at the top of the pot is cooler. Even though it's hot, it's still cooler than the bottom, right? Then that's going to sink. And that creates what we call a convection current. What happens to the boiling of a pot when you turn the stove off? What happens to the boiler? Does what? It stops, right? You remove the heat source, the convection current is done. All right, so the reason we're talking about convection currents is because we find these convection currents in the mantle of the planet. Now, what we talked about well, you weren't here when we talked about it, but the lithosphere, you should have viewed this on your day off, is broken up into separate sections called what? The outer shell of the planet. It was in one of the videos that I showed you, one of the videos I made. All right, who could tell me what the lithosphere is made up of? Did you guys all watch the videos last week that I put up there on Thursday and Friday? Yes? No? No. I'm getting a lot of blank stares. All right, so the lithosphere is the crust and the uppermost part of the mantle. This makes up the outer shell of the planet. This outer shell is not one solid piece. It is broken into separate sections called plates. Now, the reason we're talking about this is because 250 million years ago, all the continents were joined together in one single large landmass called what? Does anybody remember this? You should have learned this previous years. Pangea. So from 250 million years ago to present day now, the continents have been moving. They will continue to move. They move at about 2 inches per year. So what force is responsible for moving these continents? And it is the convection currents in the mantle. So open up your notes, please, which was the Earth Layers notes, and copy this down. Just a reminder, when you finish copying something down, please close your Chromebooks halfway so I know I can move on. Sorry. So again, just like the example I gave you with the warm air and the cold air, same thing happens in the mantle. Because what ultimately is providing the heat for the mantle, that is the outer core, right? Because isn't that the deeper you go, the hotter it gets. So at the bottom of the mantle, that rock is hotter. It's going to rise up through the mantle. The rock that's at the top of the mantle is going to sink back down because it is more dense, it is cooler. This creates a loop. So, for those of you that didn't watch the videos on Thursday and Friday, the test is this Thursday, so you need to view those because you're missing information.
Guys, you do know when you're not in school, we're teaching new material in those days that you're not here. So that's why you really have to watch those videos and do that work on that day. Then you're almost like 3 lessons behind if you don't start doing that.
So remember, halfway closed if you're done, so I know I can move on.
Still have a lot of people those are just loading.
It's still loading?
Yeah, they haven't gotten to it yet. Still.
So here, again, remember that the bottom of the mantle is in contact with the outer core, right? It's the outer core that's providing the heat in the mantle. This rock at the bottom of the mantle, because it's heated, becomes less dense. It's going to rise up through the mantle. When it gets to the top, it cuts over here. But you see how this arrow is dragging? That movement of that magma underneath is what's pulling on the continents and moving them. That now, this rock is now cooler, becomes more dense and sinks back down. As long as there's heat in the outer core, this will continue. So that's why the continents will continue to move until there's no more heat source. So copy this down, please.
Into the earth, we can begin to understand the theory of plate tectonics. Our planet is made up of different layers. The core is a mixture of solid and liquid metal. The mantle is a mass of hot liquid rock circulating in currents around the core. These thermal convection currents are the force driving the movement of the plates. The outermost part of the Earth's mantle and the exterior crust forms the lithosphere. This lithosphere, or crust of rocks, is divided into plates. When molten rock rises up out of the convection currents, the lithosphere arches, stretches, and finally bursts open. A plate is ruptured. Molten rock pushes up through a crack to the surface. Dissolved gases are released, shooting lava high into the air, and the crack widens to form a rift valley.
Okay. I don't believe there's anything for you to write on this slide. Correct me if I'm wrong. Is this slide completed for you now or no? You mean this?
No,
Oh, okay. Okay, quickly fill it in. So now what I want you to do now is on Google Classroom. I put an assignment up there. Where is it? This is it. Nope. This is it. Nope. Where did I put it? It's called Convection Currents Assignment. All right, so again, part one, and you're going to be using Cami to complete this. Again, circle for this, for the crust, the pressure, 1 being the least, 4 being the greatest amount of pressure. All right, it's very self-explanatory, this section. Now, part two, convection currents. Here you have to view a demonstration. I'm going to play that demonstration for you now on YouTube. I want you to view it. You're going to have to sketch what occurs with the cold and hot water in this diagram here. Following that, you have the analysis questions here with more questions down here. So whatever you don't finish in class, you will finish for homework. So this is the video I'm going to play for you now. So please open this up with Cami. That way at least you can get the sketch done now.
Did you know detergent leaves behind bacteria? New Clorox fabric sanitizer kills bacteria between washes.
Welcome to Moo Math and Science.
Is everybody ready for the video? Everybody has their assignment open? Okay.
In this video, you will watch a convection current demo. Convection currents occur when you have uneven heating, much like why these hot air balloons rise. Convection currents help cause some of our weather, create some of our winds, help create ocean currents. This demo should help you understand why we have convection currents. And with a convection current, you have difference in temperatures. And in this, I have cold represented by blue ice cubes. And then the hot will be represented by the red liquid in this, and it's pretty hot. Not boiling, but pretty hot. So I'm going to place the ice cubes in first, and it should, as it melts, the blue should sink down, and I'll keep that on this
And it would
side.
sink down because remember it is colder.
I will place the warm water on the other side, and let's see what happens with the convection currents. Okay, obviously the red is beginning to rise upward, and you can begin to see the blue sink downward. And we'll see if we don't get the convection current going.
You see how it's creating that loop
now? You can see the blue water, which is cold, is sinking down, and the red water, which is warm, is rising up. As the red gets to the top, it will begin to cool and eventually go back down. And if the blue water cools, warms up, then it will rise back up. So as you can see, these are how convection currents are formed. Thank you.
All right, everybody, good? Sketch that now. So make sure you complete these by tomorrow. Any questions on convection currents? Okay. Remember you have a test this Thursday, right?